Hi guys, welcome to our project, the Neuro-Symbolic Dual System on Task-Oriented Dialogue Generation. Our team members are Yifei, Yukai, Weiqiu, Liyang, and Haoyu. When doing the dialogue generation, we always face a problem that the next generation factually conflict with the previous generation. And our goal is to use the neuro-symbolic representation to improve both the consistencies and coherence in task-oriented dialogue generation. The neuro-symbolic dual system is from the MIT's paper last year. First, we have the neural system that is fast and intuitive from the pretrained language model such as GPT-3. And given a story head, the GPT-3 can generate the next sentence candidate. However, the next sentence is often inconsistent with the previous stories. Let's say, Mary dropped the apple there, but the story never mentioned Mary pick up an apple before. To address this issue, we introduced another system that is a symbolic consistent checker, which is load and logical. In detail, we will use GPT-3 to parse a role model from the current story to which contain all the status. And also, we use another GPT-3 model to parse the next sentence to the fact, and then use the symbolic system to check whether this fact is inconsistent or not with the current role model, and then reject them if it's inconsistent, accept them otherwise. By doing this, we can finally generate a story that is consistent and coherent. We first reproduce the paper on the bAbI story generations. Here, we provide the first sentence, and then the neuro-symbolic dual systems will generate and then accept or reject the next sentence continually. For example, here the system rejects Daniel travel to the garden because Daniel is already in the garden at that time.
Moving on to task-oriented dialogue, instead of generating the next sentence in the story, we generate the next response for the agent. We use the MultiWOZ dataset because it has lots of annotation for each dialogue turn. For generation, we re-implemented a strong baseline on MultiWOZ using GPT-3. The model basically conditions on the dialogue history, and it generates lots along with the response. We skipped a lot of the details here, but essentially in the symbolic component, we check the user brief states. So basically slots and user requests. The states will be updated as a result of all the parsed user actions like inform, request, and so on. At the same time, we sample 5 responses from our generation model and parse them into system actions. These system actions are checked against our consistency rules, and they will be rejected if they violate any of them. The rules can be, for example, does this agent ask for information already told by user? Does the agent answer all the user requests? The agent should ideally also try to narrow down the number of, say, restaurants that match users' interests. And here, the user asks for a hotel with free parking. And the first generation is rejected because it should probably ask for more information to narrow down the search instead of booking a random hotel prematurely. So the second one makes more sense.
We'll be evaluating our single system baseline as well as our dual system approach based on 3 different criteria. The inform rate represents the percentage of dialogues where our system provides correct entities to user requests. The success rate represents the percentage of dialogue where the informed condition is satisfied, but also all requested information are answered by the system. The blue score is a measure of the coherency of our generated responses. To have an overall quality measure, we combine the average of inform rate and success rate plus the blue score. While we're still working on the consistent checking module for our dual system approach, we have already managed to improve the consistency of our agent, which in turn increased the success rate.
To sum up, neuro-symbolic dual system can improve the consistency in task-oriented dialogue generation by rejecting system responses that are not giving user what the user is asking or is inconsistent with their previous dialogues. This improves the success rate of the goal. We still need manual inspection to check the coherence of the dialogue, as blue is not necessarily a reliable measure, as there can be different options for system responses. In this work, we only work on hotel and restaurant domains. Future works can extend it to other domains in MultiWOZ. Also, we only model the surface form of the dialogue. Future works can potentially add another symbolic system to model theory of mind of user for the system to ask better questions. Thank you for listening.